Hi ho, it's video 16-3, indicators. Okay, so indicators. Okay. Most of your indicators are going to be either a weak acid or a weak base. Okay, and there's a reason why they're used. Okay. Now indicators will change color according to a pH. Okay. And the basic way that they work, this IN here and this IN, that does not mean indium ion. That basically just means the anion for the indicator. Okay? It's a weak acid or weak base, so which means the equilibrium always lies to the left side. So when you put it in the water, you get a lot of the molecule and only a little bit of this anion. Okay? Now, how does it work? The molecule has one color and the anion has a different color. Okay? So indicators will change color only over a very small pH range. Okay? And this is known as a transition interval, so remember that term. Okay? Now, the indicator is only useful within this transition interval, meaning if the pH is between, for let's say this indicator only changes color between 7 and pH of 9. Okay? Anything less than 7, it will not keep changing color. It will always be red. Okay? If the pH is above 9 for this indicator, it won't keep going from yellow to green to blue to indigo to violet. It's always just going to be yellow. Okay? So if the pH is 10, 11, 12, 13, 14, etc., it's yellow. So this indicator is not really going to be useful because all you know it's above 9. And if the pH is 6, 5, 4, 3, 2, or anything below 7, the color of it will still be red also. So it's only useful between 7 and 9. Okay? So how do they work? Okay? Well, let's take a look at something like phenolphthalein, and this is what you guys are going to end up using. Okay? Now, the molecule is colorless. Okay? And the anion produces a pink color to it. Okay? And as long as this molecule is in excess, and it will be in excess if as you put it into acidic solution or a neutral solution, then you're not going to see anything because this molecule is present and there's no color to it. Okay? Now, if you add OH minus to it, it reacts with the H plus and it gets used up. Okay? Or basically this gets reacted, it shifts this way. You can think of it that way. You're using up the H plus. So system says, hey, I got to make more H plus, and at the same time I need to make this anion. Okay? And then as a result, as you use up more and more of the H plus, more of this turns into H plus and ion minus, and you see more and more of the pink stuff, the pink color. Okay. Now, in a titration, the base reacts with the acid that's already in the solution that you're titrating. Okay. It won't react with any of the indicator molecule until you reach the equivalence point. Okay. Now, once you reach the equivalence point, all the acid has reacted with all the base that you're adding. Okay. Now, once that takes place, if you add a little bit more base, now there's no more H plus from that acid because we titrated all of it. So the base will now start reacting with the indicator molecule. Okay, and then this stuff goes away and it starts producing more H plus and more indicator anion. And as you use up more and more of this, you produce more and more of that anion, and now you start seeing the color change. Okay, so how would you do this? Well, let's take a beaker. Well, not that kind of beaker. Okay, this kind of beaker. And we have our acid in here. Okay, so there's a whole bunch of acid in here. So a whole bunch of H plus. Okay, and we add in a little bit of indicator. So there's a little bit of this HIN molecule floating around in there. Okay, now we're going to start titrating it. Okay, and this, because there's a whole bunch of H plus in there. Okay, remember our Le Chatelier's principle. If you got a whole bunch of something, it's going to shift the other way. So Okay, because there's a whole bunch of extra H plus, okay, it shifts this way, and pretty much you're only going to have the molecule. Very little, if any, of this anion, okay, which is the different colored stuff. Okay, so now we start adding base to it. Okay, what happens? The base is going to react not with the molecule, but the base is going to react with all this extra acid that's still floating around in here. Okay, and as long as you keep adding base, it keeps reacting with all the acid that's in the solution until you reach the equivalence point. All the base has neutralized all the acid. Okay, now let's say this is the equivalence point. There's no more H plus in here. Pretty much that's all is in here is just water, okay, and the indicator now. Okay, now what happens if you add one more drop of hydroxide? Okay, the hydroxide doesn't have any more acid to react with, so it has to react with the indicator molecule. Okay, and what happens? The H and the OH make water, and then you get the anion. And this is the stuff that has the color to it. Okay, one drop past the equivalence point, you start making the anion. Then you'll see a color change. Okay, it's not shown here, but this solution would actually change color because once you produce that anion, it's a different color than what that molecule was. Okay, so here's your review question.